Probe, the most distant human-made object in the universe, is sending usable information to Earth again.
Imagine sending a message in a bottle into an ocean. But that ocean is infinite, darker than the deepest abyss, and filled with mysteries that could shatter everything we thought we knew about existence itself. Now imagine that bottle has been floating for 48 years, traveling 15 billion miles from home, and just when scientists thought they knew what it would find, it discovered something impossible. Today we're going to uncover the most mind-bending space discovery of the 21st century, one that has left NASA's brightest minds scratching their heads and questioning the very nature of our universe. September 5th, 1977. Cape Canaveral, Florida. While most Americans were listening to disco and watching Saturday Night Fever, a small team of scientists and engineers were about to pull off the greatest cosmic heist in human history. Their target? Every single outer planet in our solar system. You see, the planets had aligned in a way that happens only once every 175 years. A cosmic window of opportunity that wouldn't open again until the year 2152. Miss this chance, and no one alive today would ever see it again. The plan was audacious: build two identical spacecraft, each no bigger than a small car, and send them on a grand tour of worlds that no human eyes had ever truly seen. Jupiter with its swirling storms larger than Earth itself, Saturn with rings that seemed too perfect to be real, and for one lucky probe, Uranus and Neptune, the mysterious ice giants lurking in the outer darkness. But here's what makes this story incredible. These spacecraft were built with technology that had less computing power than a modern calculator. Their memory, 3 million times smaller than your smartphone. Their internet speed, 38,000 times slower than 5G, yet somehow these two mechanical explorers would not only survive their journey, they would rewrite the textbook on what it means to be human in an infinite universe. March 5th, 1979. After traveling for over a year through the cosmic void, Voyager 1 was finally approaching its first target, Jupiter. What it found there defied every expectation. Scientists expected dead, crater-pocked moons, boring chunks of rock like our own moon. Instead, Voyager 1's cameras revealed something that seemed almost alive. Io, Jupiter's pizza-colored moon, was exploding. Massive volcanic eruptions were hurling sulfur and molten rock 200 miles into space.
2, 1, liftoff!
Europa Clipper is the first mission dedicated to exploring Europa.
Higher than Mount Everest, covering areas the size of France. This wasn't just geology. This was a world on fire, right in our cosmic backyard. But perhaps the most spine-tingling moment came when Voyager 1 turned its cameras towards something unexpected. Rings around Jupiter. Faint, ghostly rings that no one had predicted. In that instant, Jupiter transformed from a familiar giant into an alien mystery. Then came Saturn, November 12th, 1980. If Jupiter was surprising, Saturn was absolutely mind-blowing. The rings weren't just beautiful, they were impossibly complex. Thousands of individual ringlets, shepherd moons keeping them in perfect formation, gaps and waves that seemed to dance with mathematical precision. It was like discovering that nature was a master artist and mathematician all at once. But Voyager 2's journey to Uranus and Neptune, that was where things got truly otherworldly. Winds screaming at 1,000 miles per hour, the fastest ever recorded on any planet. Moons colder than liquid nitrogen, with geysers shooting nitrogen ice into razor-thin atmospheres. By 1989, when Voyager 2 sailed past Neptune, both spacecraft had sent back over 33,000 photographs and revolutionized our understanding of the solar system. But their greatest adventure was just beginning. February 14th, 1990. Valentine's Day. While millions of people on Earth were celebrating love, one man was fighting for something even more profound: perspective. Carl Sagan, the legendary astronomer and Voyager team member, had an idea that NASA thought was unnecessary. He wanted Voyager 1 to turn around just once and take a photograph of home. From 3.8 billion miles away, what came back was a single pixel, a pale blue dot suspended in a sunbeam, looking impossibly small and fragile against the cosmic dark. Look again at that dot. That's here, that's home, that's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. In that moment, Voyager 1 didn't just take a photograph, it held up a mirror to humanity itself. And then, with their cameras turned off forever to conserve power, both Voyagers began their journey into the true unknown. For the next 22 years, Voyager 1 traveled through a region of space that had never been explored. No human-made object had ever gone this far. No signals from Earth had ever been this weak. The journey was treacherous. Cosmic rays, high-energy particles that could fry computer circuits, bombarded the spacecraft daily. Temperatures swung from scorching heat to absolute zero. Equipment that was already older than most people on Earth somehow kept functioning. But the engineers at NASA's Jet Propulsion Laboratory had a secret weapon: the Deep Space Network.
The Deep Space Network makes everything that we do possible. Imagine landing night, for example, for Curiosity. Without the Deep Space Network, there'd be no one in there because there'd be nothing to see. We would hear nothing from the spacecraft.
3 massive radio dishes strategically placed around the globe in California, Spain, and Australia, each one as wide as a football field. These weren't just antennas, they were humanity's lifeline to the void. Every day they strained to catch whispers from a spacecraft so far away that radio signals took over 22 hours to reach Earth. And then, on August 25th, 2012, something extraordinary happened. Voyager 1's instruments detected a sudden change. The solar wind, that stream of particles from our sun that creates a protective bubble around our solar system, had vanished. Voyager 1 had crossed the heliopause. It had left our solar system entirely and entered interstellar space, the realm between the stars. For the first time in human history, we had an ambassador in the galaxy itself. But this is where our story takes a turn that no one, not even NASA's most brilliant scientists, saw coming. 2025, Voyager 1 is now over 15 billion miles from home. So far, that light from our sun appears as just another star. The spacecraft is running on backup systems, held together by engineering miracles and sheer determination. NASA engineers had just accomplished something incredible. They'd brought long-dead thrusters back to life after 21 years of silence. It should have been a celebration. Instead, what they discovered in the data would leave them questioning everything. Voyager 1's plasma wave system began detecting something that shouldn't exist. Instead of the gradual transition into deep space that every model predicted, Voyager 1 hit something. An invisible barrier, an unexplained increase in cosmic radiation, magnetic field fluctuations that made no sense according to our understanding of interstellar physics. The data suggested that Voyager 1 was communicating with an energy field or form of matter that didn't fit into any known category of interstellar phenomenon. Some scientists whispered about ancient cosmic events, remnants of stellar explosions from billions of years ago. Others wondered if they were seeing evidence of structures in space-time itself. The most incredible theories suggested something even more profound. Had Voyager 1 discovered evidence of intelligence? But there was a problem. Deep Space Station 43 in Australia, the only antenna powerful enough to send commands to the Voyagers, was about to go offline for crucial upgrades. If they were going to solve this mystery, they had until February 2026. The race against time had begun. Inside NASA's Jet Propulsion Laboratory, a small team of engineers and scientists faces an impossible challenge. They're trying to debug a computer system that's older than the internet, using equipment that predates the smartphone, to understand a discovery that could reshape our view of the universe. Meet the Voyager team, many of whom have been with the mission for decades. Some were there in 1977 when the spacecraft launched. Others joined as graduate students and are now leading the mission themselves. For them, this isn't just a job, it's a lifelong love affair with the unknown. They speak to these spacecraft like old friends, coaxing life from systems that should have died years ago. The technical challenges are staggering. Every command sent to Voyager 1 takes 22 hours to arrive. Every response takes another 22 hours to return. It's like having a conversation where every exchange takes nearly 2 days. And the power situation is critical. The radioisotope thermoelectric generators that keep Voyager alive are losing about 4 watts of power every year. By 2030, the spacecraft will go silent forever. But until that day comes, this dedicated team will keep listening, keep analyzing, keep pushing the boundaries of what's possible. Because somewhere out there, 15 billion miles from home, humanity's most distant explorer is still making discoveries that could change everything. There's something beautifully poetic about Voyager's current situation. While scientists debate the meaning of its impossible discovery, the spacecraft continues to carry humanity's most ambitious message: the Golden Record. Encoded on copper and plated with gold, protected by aluminum covers, these records contain 90 minutes of Earth's greatest music, from Bach to Chuck Berry. Sounds of laughter, of rain, of a mother kissing her child. Pictures of dancers, of dolphins, of children playing. And Carl Sagan's message: we cast this message into the cosmos. A present from a small, distant world, a token of our sounds, our science, our images, our music, our thoughts, and our feelings. Now, as Voyager 1 encounters mysteries at the edge of everything we know, that record continues its journey toward Proxima Centauri, our nearest stellar neighbor. It won't arrive for another 16,700 years. But here's the incredible thing: even if Voyager 1 goes silent tomorrow, even if we never solve the mystery of what it found, that golden record will keep traveling. Long after our sun dies, long after Earth is gone, Voyager will still be out there, humanity's eternal ambassador to the cosmos. News of Voyager 1's mysterious discovery has sent shockwaves through the scientific community and captured the imagination of people around the world. Within hours of the initial reports, number Voyager discovery was trending globally. Science enthusiasts, philosophers, and curious minds everywhere began asking the same questions. What did Voyager 1 really find? Are we alone? What lies beyond the edge of our cosmic neighborhood? But perhaps the most profound reaction came from the scientists themselves. Dr. Jamie Rankin, one of Voyager's project scientists, summed it up perfectly when she said that working on Voyager has taught her that there are a lot more mysteries out there than we ever imagined. The truth is, we may never fully understand what Voyager 1 discovered in interstellar space, but that's not really the point, is it? Voyager's greatest discovery isn't what it found out there in the dark. It's what it revealed about us. About our curiosity, about our courage to reach beyond the comfortable boundaries of home and ask the biggest questions imaginable. In 1977, we built 2 spacecraft with the computing power of a calculator and sent them on a journey to infinity. Today, nearly 50 years later, they're still out there, still exploring, still surprising us. And that perhaps is the most human thing of all: the refusal to stop exploring, even when the journey takes us to places we never imagined we could go. So the next time you look up at the night sky, remember, somewhere out there, 15 billion miles away, 2 small spacecraft built by human hands are writing the next chapter of our cosmic story. And the best part? They're just getting started.